Question 3. The parametric equations of a curve are given as x equals 3 minus cos 2 theta and y equals 2 theta plus sine 2 theta, for theta in between 0 and pi over 2. Take note that this is the first quadrant. All the trig ratios are positive. We need to show that dy dx equals cotangent theta. In order to find dy dx, first we must find dx d theta and dy d theta. Dx d theta, we just differentiate 3 minus cos 2 theta with respect to theta. When we differentiate cos theta, we get negative sine. So that negative is gone. We have sine 2 theta, and then you need to differentiate the inner function, which is 2 theta. That gives you a value of 2. So that dx d theta is 2 sine 2 theta. Y is given by 2 theta plus sine 2 theta. So dy d theta, when you differentiate 2 theta with respect to theta, we have 2, and the derivative of sine is cos. So you are cos 2 theta, and you need to differentiate the inner function, which is 2 theta, so that is 2. dy d theta is 2 plus 2 cos 2 theta. Show that dy dx is cotangent theta. dy dx, that is given by dy d theta over dx d theta. dy d theta is 2 plus 2 cos 2 theta, and dx d theta is 2 sine 2 theta. What we need to show is cotangent theta. So we need to apply the double angle formula for sine and cos. The double angle formula for cos, we need to pick 1. Cos 2 theta is given by cos square minus sine square. We also have 2 cos square minus 1, or 1 minus 2 sine square. Cotangent is cos over sine. So what we need to do is we need to eliminate these 2. We need to pick 1 with a negative 1 so that 2 can be eliminated. So we replace cos 2 theta with 2 cos square minus 1. The denominator, you have sine 2 theta. The double angle formula for sine is 2 sine theta cos theta. Expand the numerator, 2 plus 4 cos square theta minus 2. The denominator is 4 sine theta cos theta. That 2 cancel off. We have 4 cos square in the numerator and 4 sine theta cos theta in the denominator. The 4 can be cancelled off. One of these, the cos can be cancelled off, so that we have cos theta over sine theta, and that is cotangent theta. Question 4. Solve the log equation. You have a log term on the left and a log term on the right with a constant. In order to solve a log equation, the log terms must be grouped together. So we move this over to the left. We have log of 2x plus 1 minus 2 log of x plus 1 equals negative 1. Then we need to make the log terms into one single term. Applying the power law of logarithm, that 2 can go back here to become the exponent of x plus 1. log of 2x plus 1 minus log of x plus 1 squared equals -1. Then we use the quotient law to group these two together. Now recall that log A minus log B is log of A over B. That gives us log of 2x plus 1 over the square of x plus 1 equals -1. Take anti-log now. 2x plus 1 over x plus 1 squared is 10 to the -1. 10 to the -1 is 1 over 10. We can write 2x plus 1 over x plus 1 squared is 1 over 10. We can cross multiply so that 10 times 2x plus 1 equals the square of x plus 1. Expanding on the left, 20x plus 10. On the right, when we square x plus 1, we have x squared plus 2x plus 1. Rearrange everything, just put everything on one side so that x squared plus 2x plus 1 minus 20x minus 10 equals 0. X squared minus 18x minus 9 is 0. This is a quadratic equation. Unfortunately, it cannot be factored. The answer must be correct to 3 decimal places. What we could do is we could use the quadratic formula. X is -b plus minus square root of b squared minus 4ac all over 2a. Let's look at this equation here. A is 1, B is -18, and C is -9. So we replace the values of A, B, and C in the quadratic formula with whatever we have here. Negative of -18 plus minus square root of -18 squared minus 4a is 1, C is -9. All over 2a, a is 1. And this gives us 18 plus minus square root of 360 all over 2. X is 18 minus square root of 360 over 2, or 18 plus square root of 360 over 2. The first part gives us an answer -0.487. The second, we have 18.487 to 3 decimal places. When solving a log equation, you have to be very careful here. You need to make sure that the answers are valid. Log is only defined when the arguments are positive. So for each of these x values, you need to check that the arguments are positive so that the answers are correct. So the first case, when x is -0.487, x plus 1 is greater than 0. That is fine. Then check 2x plus 1. 2x plus 1, this is just -0.9 at the maximum. So this is also greater than 0. Then this answer is valid. The second case, when x is 18.487, well, clearly x plus 1 is positive and 2x plus 1 is positive. So this answer is valid as well.